Uh, to share this. That's not what I wanted. Interesting. Mm, maybe for the people who are watching videos, because I'm gonna guess most of you guys have the calculations thing is due technically on Wednesday, 16, 17. All right. Sorry. It's getting sunnier. People don't want to stay inside. Some people don't care. Last week we talked about types of reactions. So formation, decomposition, single replacement, double replacement, and combustion. They all have a different kind of set of reactants usually. A synthesis reaction is two elements or formation or whatever. Decomposition is one thing falling apart. Single replacement is an element and a compound. A double replacement is usually two ionic compounds. And a combustion is some sort of CH thing and oxygen. I asked you to go through these, um, which I just totally, Friday afternoon was a bit chaotic, so I didn't get this looked at until this morning, and I will put them all up there. None of the equations were super complex in terms of balancing. There was no real crazy things. When you have polyatomic ion switching or you have falling apart or making new ones, those get a little bit tricky, but I I went through this in I think maybe 5 minutes. But again, like something like that was a little bit. But today I want to go through, well, we did combustion as well, predicting the products, what type of reaction is going on. And I'm going to go through some of these. There's a couple that we probably will just ignore. And I put a part 3 for the notes for chapter 11. And I think it ends here. And these are what type and predict the products. Uh, and then I'm torn as to whether to do the ionic compounds and net ionic equations, but it's important. But yeah, we might try to squeeze it in tomorrow. So we've already done a little bit of predicting products because if you were asked to predict the products, you need to know what type of reaction it is. So I've got four things here, obviously formation, decomposition, single replacement, double replacement. And these ones don't ask you what type, but it's something that you need to ask yourself. And then if it's formation, what type of compound can you form? Normally for a formation reaction, unless I specify something, it's usually going to be ionic because if it's ionic, you know charges. If you know charges, you can write a formula. If it's molecular, who knows? Decomposition falls apart into elements. We're not going to try to worry about, there are some decomposition reactions. There's kind of a famous one that was in here. Maybe it's on the page above. Not specifically, it's kind of that one. Oh, here we go. It's the same thing. Potassium chlorate is a an ionic compound. It's a white solid. If you heat potassium chlorate up, you get KCl, which is fine, and you get oxygen. It's a way to generate oxygen in a lab if you don't have a cylinder full of oxygen. You can do it under an like an inert atmosphere, do it in a bottle, generate oxygen, and use it. I'm not going to say, oh my gosh, if I give you this and you remember that it makes salt and oxygen, that's great. But if you said potassium, chlorine, and oxygen for us, that's what we're going to look at. So this first one, aluminum, that's an element. Fluorine, that's an element. That means its formation. This is the metal, and that's a nonmetal. So we need to make an ionic compound. So if it's ionic, I need to know what two ions we're going to have. Well, aluminum, based on where it is on the periodic table, is aluminum plus 3. Fluorine becomes fluoride minus 1. Well, what type of compound is made when you have a plus 3 and a minus 1? But AlF3. And that's the hardest part of predicting the products is usually what type is it, because some people will get hung up, well, that's a molecule and you're going to have ALF and then F, and it's a little bit nonsensical. Write an ionic compound. It's the same, the ability to do this comes from chapter 7, 6, 7, 7. And you've all done it. I mean, the what, 6 of you? 5 of you have all done that before. So that's a formation reaction is usually going to be an ionic compound unless you have something like H2 plus O2. Well, that's probably going to make water. And carbon and oxygen, carbon dioxide. Um, I don't know if there's any that we have to worry about. So one thing going, this must be decomposition. Well, what two elements are there in that? Well, we've got boron. Oh, and we can balance that. Technically, you need to balance it. Boron and hydrogen. Boron is boron. B. Hydrogen is one of the Brinkelhoff or diatomic molecules, so this must be H2. So whatever elements are there. If you write that as H, it's not correct. Hydrogen, when you produce hydrogen, when you produce oxygen, fluorine, chlorine, bromine, iodine, hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine, they're going to have to be diatomic. If you wrote B plus H and did, well, this one's going to be a 2, and you put a 6H there, straight up, I'll give you marks for that, but not for that. That's a 3, boron plus hydrogen. And you're just writing elements. So if you have phosphorus and bromine, what elements are there going to be? Hydrogen peroxide, what elements are there? Those are all, none of those are decomposition. But whatever elements are there. Element, compound, has to be single replacement. Well, what type of elements are those 3? Metal, metal, non-metal. So what is going to switch places but the sodium and the aluminum? So you would end up with aluminum and the compound of sodium and chlorine. What I would expect is just the formulas, but I'm just talking through this. Well, the formula for aluminum is Al. Sodium, when we do this, becomes +1. Chloride, we know, is -1. So we know that's going to be NaCl. And then we balance 3 chlorines three chlorines, three sodiums. So that is a single replacement reaction. Again, it's identifying. A lot of this stuff ends up being ionic or ionic-like. We talked specifically about combustion Friday or Thursday, so I'm not super worried about that. This is an ionic compound.
McKay.
Jesus. Sorry.
Sorry. I'm sorry. I didn't mean to interrupt you.
No, no, that's fine. It's my nerves that um it because it's not like in class where I can see or whatnot, and I was just going, and all of a sudden, whoa.
Okay. Well, I'm gonna leave
Okay,
because I just joined, but I'm at my mom's and I don't have any of my stuff.
no worries. I'm recording it, and we'll put it up to take a gander if you need to.
Okay, see ya.
Bye. Calm. I need to. Okay, I'm gonna take a drink. Watch Community. It's a great show. 6 seasons in a movie. So compound and compound is this is double replacement. So we need to worry about charges because these are usually like 99 times out of 100 ionic. Lead in this compound is +2 because nitrate is -1. +1. Oh, that would be bad. -1. Okay. So when we need to write the two new compounds, well, I'm going to start with lead because it's right here. It's +2. It needs to join with the negative ion from the other side. So Pb with a -1 means Cl2. The nitrate here joins with the positive there because the signs or the charges are opposite. Sodium nitrate, NaNO3. Two nitrates, two nitrates, two sodiums, two chlorides, and that goes there. One of the things, nitrates all dissolve. Every nitrate that ever existed dissolves. Lead 2 chloride is something we'll talk about a little bit in terms of solubility because we said last week the driving force of a double replacement reaction is either making water or forming something that becomes a solid. And lead 2 chloride is a nice shoot. Lead 2 iodide is nice and yellow. I can't remember what color lead 2 chloride is. Might be yellow, might be orange. I don't know. But that's the gist of double replacement. So those are the four types. That's the stuff on the next kind of 3 pages. I'm going to go through a handful of these, how I would go through them logically. Um, Probably look at 4 is one that's kind of special that I would never give on a test, but there's decomposition, there's some combustion. So sodium is an element. FeBr3 is iron 3 bromide. That's a compound. So if it's an element in a compound, this is single replacement. Sodium is a metal. It makes things that are +1. It's not +1 now, but if it makes a compound, it's +1. Bromide is -1. There's 3 of them. That's +3. So if we use this idea of charges, sodium is going to make a compound with bromide. Well, +1 and -1. Those are going to form together. What's left over? Iron. We have to balance, which is fairly simple. There's 3 of these, so I need 3 of those, 3 of those. So that's single replacement. Sodium hydroxide's a compound. Sulfuric acid's a compound. Okay, so if it's a compound and a compound, it's double replacement, which is where number 4 gets a little into problems. Sodium +1, hydroxide -1. hydrogen in an acid, +1, sulfate, -2. So positive of one, negative of the other. And I've never actually drawn the lines underneath, and I think that's something I'm going to start from now on. So sodium and sulfate, Na, well, I need two of those to make that. What's left over? And if I'm doing a double replacement reaction for balancing, HOH is water. There's You can write it as H2O. I will, if I'm doing any answers or keys or anything like this, I'm writing HOH because it's easier for me. And that's the two things we want. two sodiums, two hydroxides, two hydroxides. That single H comes from there. We color code things, and that one is done. So that's a double replacement of something, something, something plus oxygen. Burn it up. Uh, C2H4O2. Uh, Propylene. No. Ethylene glycol, maybe? I don't know. But if it doesn't say anything, if it's combustion, we assume it's complete combustion because that's the easiest thing to do. Carbon dioxide and water. Two carbon, four hydrogen, four hydrogen. 2 times 2 is 4. 4 plus 4 is 8 oxygen. 2 is tucked away. We're not going to do anything. 8 minus 2 is 6. So we need a 3 there. Now I'm wondering what that could be. 4 is something that if you keep going in chemistry, you'd be expected to know what happens. Um, Technically, this is a formation reaction, even though it's two compounds, because we get one product effectively is ammonium hydroxide. And 3 plus 2 is 5, 4 plus 1 is 5, and 1 oxygen. It's formally kind of right. It's not totally right, but that's the way we need to go. I'm going to do 5, 6, and hopefully there's 12 is fun. Oh, I guess there's no, that's the only formation one, but come on. Down here, formation, formation. So lead sulfate and silver nitrate, compound, compound. So this is double replacement. Sulfate is minus 2 means this is plus 2. Silver is plus 1, minus 1. Plus 2 and minus 1. Lead 2, nitrate, silver and sulfate. So I need to get to minus 2. 2 plus 1s should balance that. All nitrates are soluble. That's going to come out as a solid. 2 silver, 2 nitrates. What's a 2 there? One thing and an arrow. Decomposition. What two elements are here? Phosphorus and bromine. If we write bromine like that, Mr. McKay, if we were in class, would have a bit of a conniption because bromine is the first part of Brinkelhoff. So we have to do that. Those are the elements. Balance, oh, a 3 and a 2, that's yucky. So that's 3 and 2. So far, so good for the group of you that are here. I hope so. I want to know who that is. With the, I don't know what thing that is. Like some people have pictures, some people don't. This team thing is really nifty, but compound, element, whether it would happen or not, technically I don't remember if this one happens. Single replacement, +1, -1. Uh, let's say this becomes +3 for fun. So -1 goes with the +3. So we need 3 bromides. What's left? Well, hydrogen. Write it like this. I have a conniption. H2, HOF, H. 3 bromines and 2 hydrogens means I'm going to want 6 of those, 2 of those, 3 of those, and 2 of those. 2s and 3s, if you have something that's a 2 and a 3, just intuitively, eventually you'll see that 6 is going to become somewhat handy. Potassium permanganate, deep purple, +1, -1, +2, -1. This is a double replacement. Potassium chloride plus zinc permanganate. That's going to be a 2. 2 chlorine, 2 chlorine, 2 potassium, and 2 permanganate. And we go to there. This one's a little bit odd. +4, -2, +4, -1. This is a double replacement-ish. +4 goes with -1, manganese, hydroxide, not twice, but 4 times, +4 and -2, SNO2, not snow like that awful crap that we had on the weekend. It's May. I keep saying to my wife, next thing comes locusts. And she's like, why do you keep saying that? Well, because wasn't that one of the plagues in the Bible, locusts? We've got pandemics and all this foolishness, and then it snows in May. Ben was really happy. I want to go play in the snow. No, we're not going outside. It's no, sorry. Oxygen and some hydrocarbon is a combustion. Now, if I didn't say what type of reaction it was, and you did incomplete combustion, I would be like, yeah, that's not really what I wanted, but whatever, because it's a possibility. Ooh, 5, 6, 2 5s are 10, +6 is 16. 16 -2 is 14. 14 divided by 2 is 7. Oh, one thing in an arrow. That's decomposition. What 2 elements are here? Hydrogen and oxygen. If you do this again, I freak out and kick and scream. Hydrogen gas, oxygen gas, hydrogen peroxide. That's kind of what goes on when you put it on your skin. And this one is here. It's really fun to give in class. +4, -1, -1. Technically, this would be a single replacement reaction if anything visible actually happened. Platinum goes with chloride. Chlorine is left over. Technically, there would be no visible reaction. But if you write PtCl4 and Cl2, That's fine. And that's kind of your practice is to finish the last bit of stuff. I'll go through them and put answers up so you can look at them. For the couple of you that weren't around this morning, Ben Sitter started taking kids back. So I have a little bit more time. Not a whole lot, but a little bit. So hopefully I can get a few more things back. Um, but if nobody has any questions, that's all I had. Oh, I don't think I need to turn that off. To worry about today. Let's see, I keep pushing the screen back so it's easier for me to see. I could go down. The stupid sun. I don't know. Any questions? If not, we'll meet back here tomorrow. Same bad time, same bad channel.
Thank you.
You're welcome.
Thank you.
You're welcome. Bye.